This is Form 5, Chapter 10, Linear Programming, Part 2. If you have arrived here by accidentally or not intentionally to receive this video, I will advise you to refer to my Part 1, because Part 2 requires those who have learned and practiced in I've shown in video 1, and you should have at least 1 week of own practice on those questions. The ability to look for the region, shaded area region, and to sketch, ability to sketch those straight lines, and so that we're able to identify which region for at least 20 to 30 questions. So for our part 2 here is that for inequalities in this chapter, we will come to have some term like some parameters, some box A not more than box B, or not more than a number. So if you were to see those keywords like not more than, meaning it has to be less than or equals to. Say A is not more than B, then it will be, it sounds like this. Okay? Or A is not more than double of B, so A is not more than 2B. Okay, so this is meant by that. Then another term, and it will be represented by a solid line. Yeah, it will be a solid line. At least, or at most, sorry, the first one, second one. At most is maximum. At most, that would be at most 50. So A is at most 50. At most, maximum is only 50. So this is how it should look like. Therefore, they should have the same sign, less than. Or sometimes you will see at least, or a maximum. Therefore, it will be A must be at least 100. At least 100. So therefore, you should have this sign. You can't have a maximum, because the maximum wise then will be less than, not right. And then how about minimum? You have a minimum number that is actually at least. At least, or maybe a minimum number. Minimum number of A has to be 100, so it will be more than. So these are the keywords that you will find. And if you have gone through those work in last week especially, then you should be able to sketch those lines. But when it comes to real question, what happened is, especially in a SPM question, what happened is the question wouldn't be a straightforward question. They would normally be in word form. Say for example, some factory produce, to summarize it, let's say they say they will have some factory produce 2 types of handbag, 2 types of handbag, handbag A and B, and then the factory produce X bag A and Y bag B per day. So how you do that is, the easiest way I will find it, I would advise you to do would be to put them into a table. 2 types of handbag, maybe handbag A, handbag B. Okay, or yeah, okay. Then the handbag A, handbag B. Okay, the table. And then produce X bag A and X bag B. So number. So this is number. x back A, so x back A, and y backs B per day. Per day. This is per day. Okay. Then the time taken to do the final touch-up is 4 minutes for A, so the time per unit is 4 minutes, and 3 minutes for B, so this is 3 minutes. So it will be quite clear to you if you put it into a table, and the production subject to the following constraint. Then they will say, oh, okay, we have this information, summarize them into your answer. Then we will do what the number of bags is A not more than 250. Number of A not more than 250. So A, the number of A not more than 250. So it will be not more than 250. Then it will be like sounds like this. So first equation, you get some marks here already. Okay. Then the number of B is more than twice the number of A by at most 60. So B is Y. The number of bag B is more than twice the number of A, by most by at most 60 plus 60, I would say. More than by most 60. Yes. Or by most, more than by most 60. Oh, by most is 60. So more than by most is 60. Therefore, I would say this is by most is 60. More than by most 60. So this is how it looks like. More than by most is 60. Okay. The total time taken to do the final touch-up should not be more than 28 hours per day. So therefore 4x plus 3y should not be more than 28 hours. So if 28 hours, you times into minute, you times it with 60. Therefore, the time is less than 1640. No, 1680. Okay, so with that, then you have 3 equation. Then first part, write down 3 inequalities. This is what you get. Besides x is more than 0 and y is more than 0. Then using 2 cm represents 50 bags for both axes. Shade the region. So what I have here, if you have a graph paper at home, then you should have a graph that looks like this. Now it doesn't have a ruler, so those line is crooked, not a straight line. But here I just show you how to solve problems in SPM. You should use a ruler and to label, label the y-axis, positive y, label the positive x, so the 0, and the scale according to what's given in the question. Label them, and then you should get some marks over here. Then another part before the end. Then find the range of bag A they can produce per day if 300 bags are produced. 300 B bags. So B is represented by Y. So we're going to do the range of A if 300 B produced per day. What you're going to do is you have a ruler. If 300 Y, so this is a line where 300 Y would happen. Okay, so this is a 300. This is Y 300. This is where the bag Y is 300. This is 300. Sorry, 300. Y represents 300. What's the range of X? So the range for us would be somewhere from here I mean, you draw a straight line. You need to draw a straight line using a ruler instead of freehand. Here to here. My scale is not up to scale, so you can't really read it. So yeah, therefore you find what's this answer, and what's this answer. Therefore the range would be from here to A, number of A, number of back A, and then less than x2. So this will be the first part. Then another part would be they ask for find the maximum profit of a factory if profit sales of A and B are 25 and 20. So what you can do, you need to go back to your table. If bag A will be selling A is selling 25 and 20. So from here you need to find out what's the maximum profit. Okay, maximum profit. To do that, you need to have profit line. Equation for profit line. Equation for profit line. Okay, how you do that? It will be like this. Number per day is X. 1 unit is 25. So assume the number of profit line. Let's say my profit line is P, profit. Okay, so therefore my profit per day will be actually 25x plus 20y, right? No doubt. Okay, just that now you need to find for what is the profit. So if I were to transfer this equation to the next page, 25x plus 20y. So part 2. The profit line P is 25x plus 20y. So you can't really do what differentiation, maximum, minimum, differentiate it, because it doesn't know what's profit. You want to find what's pretty max. So first of all, you assume, just draw a line along, just draw a line in between the region. Assume there's a line there, but how can you assume that? Assume a profit P is any number in between here, between this region, a number that could be divided by 20. I would say maybe 200 or 250. Maybe I would say 250. 250. If a profit is 250. Okay, so what you could do would be, therefore you substitute this number. This number is assumed, yeah. You may use other number, any number you can think of that can be divided by both number. So therefore 25x plus 20y is now 250. Then you will be able to form a line. In my first part video, you were taught to achieve something called standard equation or general equation. Okay. So next we could do is y would be negative 25 over 20 x plus 250 by 20. So this number is rather too small, because it's by 20, then it will be too small. Then how about I change it, instead of profit 250, I change it to, say my profit is now 2000 instead of 250. I change it to 2000. So 2000. So therefore my y will be equals to negative x plus here's 100, so therefore plus 100. So I will have a linear line. I will call this as my profit line. So this is my profit line. So you want to sketch it 100, so I'll go to 100. This is my y-intercept. Okay, gradient is negative, so you should go up to down. 5 over 4, so 5 part over 4 part, that would be maybe the y's go down 5, 1, 2, 3, 4, 5, then 1, 2, 3, 4, then you get line. But easier way, that would be when y is 0, x would be 400 by 5, that would be 80. So 5 is 80, that was somewhere here maybe. Then you may use a dotted line or solid dotted line, easier to identify them. So this is my y equals to negative 5 over 4 x plus 100. This is my profit line. So next thing you do is you have two ruler. One ruler lay on it, another ruler lay on the side, and then you push along it. Okay, so you have one ruler here lay onto the profit line, and then another ruler perpendicular. I mean a thicker ruler. Another ruler you lay perpendicular to it, so that the first ruler is perpendicular to the second ruler. They are perpendicular, so that they are perpendicular here. And then you fix this ruler, longer ruler, and then you push this ruler, make sure they are perpendicular along it, and look for where the region you have a maximum point, which somewhere you touch it somewhere here, I think, somewhere here, I guess, and eventually you read for the coordinate. What's this coordinate? Okay, this graph is not up to scale because it looks like, oh, okay, you can't really see it. You push this ruler up until you found a point that represents a number of black A and black B. What's the coordinate? This is the x1 and y1 coordinate. And this will be the number to get a maximum profit. Then next thing you will do is to substitute them into the equation. Therefore, the maximum profit, y, right, maximum profit P max, you do not use this equation, but you use, this is the profit line equation. This is what you need. You therefore 25 times the number x1 to be maximum, plus 20 ringgit for y1, which is the oh no, this is a max, maximum x. This is a maximum y, which is represented here. It's not 1, but this is max 1 and max 2, the maximum for coordinate y. Then therefore you get the value. And of course you don't forget that this is ringgit Malaysia, forgotten. Therefore you have your ringgit Malaysia and you find out what's the value. So this is how you normally solve it. There are some other options if you doesn't have ruler, too long ruler, and you find it very hard to push it along it. Normally the answer would be at its vertex, would be the either here, here, or here. will be at either this point. So all you need to do is you read this 4 coordinate and you substitute into here this equation, and you find out which 4 value give you the maximum number. Normally will be at the vertex. Okay, normally will be at the vertex. So there are 2 methods. One is use ruler, push it up. Another method is you compare all 4 values. You substitute all these 4 values into the profit line to read for its maximum value. I mean, to compare those values and look for the maximum value. Okay, so this is how you want to find out what's the profit line. So I think that's basically all about it. If you want other part of it, you say like, oh, what is the intent to have the same number of x, same number of y? All you need to do is, if they want the same number of x, same number of y, then that would be sketch a line y equals x. So if you manage to sketch a line y equals x, I mean, it's quite messy here already. So another part, if you want x equals to y, then you sketch a line and then find the maximum number of each back. All you need to do is look for the intersection where they intersect. Maybe if a line y to x, this is my x. So maximum value, so this will be maximum value. That will be the third part. How many backs? Okay. I think the question in SPM will be quite standard. They will normally in this form, can't run far apart. Okay. All you need to do is to at least practice for about 20 questions, and then should be doing quite well. The tricky part along the years, students find hard would be here, the profit line. They can't decide so difficult because you need to assume profit line is P, and then assume the value. Thumbs of rule would be this value could be dy by dy value easily. Okay. You don't choose a so small value because it's rather hard to sketch it here because it's so down here. It's very hard. Find a value, maybe one order greater than the value of y. Then arrange them. You will be able to get a profit line. Sketch it, and then you will be able to find out where it intersect. Or if it doesn't want to sketch this profit line, all you need to do is to substitute with the vertex value. But sometimes it's rather hard because you have 1, 2, 3, 4 points. Sometimes could be up to 5 points. Then the substitution part is rather hard. I mean, it will be time consuming. You don't have that much of time. And I would advise students, in order to solve this question, you are not supposed to spend more than 25 minutes. Yeah, the total time to spend over this kind of question is no more than 25 minutes. Possibly at 20 minutes, you're supposed to finish every question in this section in no more than 20 minutes. Maximum is 25 minutes. Ideal time is 20 minutes. It's possible to do that if you have sufficient training. All you need to do is you go through 20 to 25 questions. Again, it's always the same thing. 25 questions of this. Time yourself 20 to 25 minutes. 20 to 25 minutes for one question. And give yourself a week time to finish 25 questions. And you check with the answer if you get it correctly. It's kind of a bonus question. I hope you will do this. You will choose this question to do because you may choose not to do this, but you may try to choose. You may want to choose it. And that's all for Form 5 syllabus. I hope you will like my video. If you really like, what I want you to do is they won't cost you anything. To press on the thumbs up button in YouTube, it means that you like my video. And the number of likes shown in each of my video really inspire me to make more videos. Even if you don't have that likes video, I will still make more videos, but I just want to help. And if you find it useful, I don't mind. I don't mind that you share with friends. Yeah? And that's all from me. I wish you good luck in your SPM. By the end of the year, getting an A in AdMaths, it's not something can be achieved. It's possible with sufficient training, and every 25 questions per week, that's something that you should look into to get you an A. That's the path where you should follow. So stay tuned to my next channel or next video. That will be in other subject. I hope I will be able to make more videos for other subjects as well. With that, thank you and good luck.